A concrete beam AB of span 20 meters is post tension with an initial stress at jacking end A as 1000 Newton per mm square. The profile of the cable is parabolic with an eccentricity in the center span as 400 mm, whereas at the supports it is concentric, so eccentricity is 0, given nu as 0.35 and k as 0.15 per 100 meters, that will be equal to 0.0015 per meter length. First is assuming the jacking end as A, compute the effective stress at B. When jacking end is at A, then let us find loss due to friction, that will be equal to initial stress P0 at A into mu alpha plus kx. Alpha is change in angle, cumulative change in angle. So let us take here angle is theta, here also it is theta, then alpha will be 2 theta, which will be equal to 2 times of theta is 4e by L. So that will be equal to 2 into 4 into eccentricity is 400 by span is 20 meters. So 20 into 10 power 3, which will be equal to 0.16 radians. Substituting, initial stress at the end A is 1000 into mu is 0.35 into alpha is 0.16 plus k is 0.0015. X will be equal to L into, so L is 20, that will be equal to 59 Newton per mm square. So the effective stress at end B will be equal to stress at A 1000 minus the loss 59, which is equal to 941 Newton per mm square. Whereas in the case B, if the cable is tensioned from both ends A and B, it is tensioned from this end and also from this end, then let us take a point C in the middle. Up to AC we will consider. In the AC length, alpha will be 0.08 itself, that is just theta, that is 4e by L. 4 into 400 by L is 20 whole into 10 cube to convert into mm, so that will be 0.08 radians. And x will be half of the length, that is L by 2, which will be 20 by 2, that is 10 meters. So the loss now will be, loss between A and C will be P0 into mu alpha plus kx. Initial stress is 1000 into mu is mu is given as 0.35 into alpha is 0.08 plus k is 0.0015 into x is 10 meters now. So that will be equal to 43 Newton per mm square. So the effective stress at the center span will be, at C will be initial 1000 minus the loss at 43, that will be equal to 953 Newton per mm square.